Chapter 4, Exercise 3.3. A box slides down a smooth plane. So usually when they say smooth, what they mean is that you can neglect the friction. So the plane is inclined at 20 degrees above the horizontal. So what they are giving you is this angle over here, 20 degrees. What is the acceleration of the box? So whenever you have a question like that, the first thing to do is to draw a free body diagram. In this case, I don't have a protractor on my computer, so I won't be able to check my answers using the protractor and the ruler. Of course you could on your notebook. So I just drew a conceptual free body diagram, and what you need to make sure is that okay, that's not really good. The y component of Fg, which is over here, is balanced out by the normal force. So this is Fgy over here, and this is Fgx. The velocity is downhill, and the force that is responsible for the acceleration of the box is Fgx. So we'll use the x-axis to apply the first principle, which is Newton's second law, and that says that the sum of the forces along the x-axis is equal to the mass times the acceleration along the x-axis. Now along the x-axis I can see that Fn doesn't have any component because Fn is along the y-axis. So only Fgx is along the x-axis. How can you calculate Fgx? So you can use that triangle there. So we have a triangle like this with a right angle over here. This angle is 20 degrees. This side is the hypotenuse, and it's also m times g. So Fgx is the opposite, is on the opposite side. If you look at the 20-degree angle, Fgx is this side, which is on the opposite side. So it's going to be m times g, which is the hypotenuse, times sine 20 degrees. Okay, and again, this is the opposite. So Fgx is m times g times sine 20 degrees, and this is equal to mass times acceleration. Because you solve in symbol, you can actually solve that problem. Without symbols, you couldn't do it, because the mass is not given. The mass is not provided, but it cancels out when you carry the calculation using symbols. So you end up with an acceleration equal to g sine 20 degrees. This is your final answer. You can plug in numbers now. So g is 9.81 meter per second squared. Sine 20 is given by your calculator. And finally, you need, so just give me a few seconds that I use my calculator, and I found AX is 3.36 meters per second squared. Now the question was, what is the acceleration of the box? So I should provide an answer in the vector format. 3.36 meters per second squared to the right, I mean along the x-axis.